Hey Drew, hey Rama.
Hi, hi, Yogesh. How are you?
Long time. Where are you?
And I get with all the fleet fun, and yeah, yeah, some yeah,
Yeah, I've been thinking about it. It's been a while since we chatted. You've been missing in action generally.
RAS API. Like I know I missed it. I know Carlos and Drew helping. I got
Right.
project to do some lot of interviews in between.
Understood.
Yeah,
Yeah.
yeah, yeah. But I am actually working with Drew and Carlos offline. Yeah,
Yeah, we have a good team now. It's exciting.
yeah, yeah. We have like a lot of discussions happening, and yeah, yeah,
Yeah.
Like a mini OCP discussion. Yeah.
yeah. I don't know. Yeah, there are so many OCP work we are doing.
No.
How are
OCP
you,
is
Yogesh? How are you doing?
doing well. Doing well. I think similar story. OCP has got its tentacles everywhere, right?
Yeah, yeah.
That's a good thing, I guess. Drew, I'm going to put something on your calendar for Monday to talk about some things.
Sounds good. Let's see.
Um,
Oh, yeah, Monday, afternoon is generally open except for 2 to 2:30
okay, sounds good. Thank you.
Pacific time.
Uh, One
Yes.
question, like, uh,
Uh-huh.
like the plan for the Nest OCP will hardware fault management has like two things, right? One is in-band fault management, other one is the CPAD, right? Is that correct?
So CPAD, we're collecting feedback, but we're going to move it to RAS API, right? This will be defined in RAS API completely, and then move to whichever standard. I think it will be part of same standard UFI as CFR. So that's the plan.
Oh,
Uh, yeah.
one question, RAS API will come later, right? Maybe this year 1.0.
I think we can get it this year. We can get it done
Okay.
this year. Yeah,
Yeah, yeah.
we have to
Yes. Yeah, yeah,
because I
yeah.
think we are at a point where we just have to define the commands and the bindings that we need to create, and that would be pretty much it. And then yes, we have to define lots of commands and for actions and all that, but we're there. We're pretty close.
Yeah, yeah, yeah. Like, uh, yeah, that's okay. I think if it is getting delayed, like adding that CPAD, that is a critical requirement, right? Adding it.
No, the CPAR and CPAD are two critical data structures, and then comes the commands for discovery and actions. So that will define, right?
Okay. Yeah, yeah.
Yeah, absolutely. So yeah, we already started putting things in the doc. Take I'd like you to take a look also. I think offline is fine too if you cannot join the meeting.
No, I will join next one. Yeah, yeah. Last month was a little bit crazy. Yeah.
Okay.
So
Yeah.
I think you guys. I was going to suggest we've got a lot to read in the doc. I think we want to just power through, right? The stuff Anil and I are working on in the doc. Is that the agenda today?
For this meeting, yes, I think Anil wanted to continue on in-band, uh, and I think we all need to finish it up. Did Anil just join?
Yeah,
Yeah,
yeah.
he's
Uh, okay,
and
so that's
Anil,
great.
I worked on the errors. So I got the proposed system error handling capabilities. That's kind of I think where we were, and I studied that today and cleaned it up. So Anil,
Drew,
okay
I
with you?
think you have the same audio issue you had last time. Something is not quite right.
Oh,
Uh,
maybe
you had to fix it last time also, I think.
Yeah, I can barely hear you.
is that better?
Oh, wow.
Yeah.
Yeah. What happens is every time I change video conferencing app, it chooses a random mic. And so I was using a mic on a headset that's like in a dock on my desk. Sorry about that.
Yeah,
Yeah.
that
Yeah,
explains it.
so I saw your changes. So Yogesh, are we ready to jump on the real
Let me
time?
just ask if anyone else has any opens before we start in the
One
agenda for
question,
today, which is
one question,
yeah.
Yesh, like what will be after in-band, right? Now we have RAS multiple work streams, right? Okay, RAS API, some other like GPU RAS. What will be for hardware fault management? Like what are the next problems we need to solve uh, after in-band? Maybe we should maybe
Yeah, maybe
two.
we should get together. There are things which I've been thinking about, which we need to discuss, and yeah, that's
Yeah,
a good point.
I've
Rahul.
got
Let's
some
start.
I've got some things I want to cover as well.
Yeah,
By the way,
maybe next week or something.
there's a spreadsheet where we fill in. Anybody can add like a topic or problem statement, the pain point that we should work on solving.
Yeah.
Yogesh, you want to share? You want to share the pointer so that all the team members can populate a pipeline of future topics.
Yeah.
Yeah,
The reason
let
I
me
was
take
asking
it
is
out.
like understand the pipeline and like put a common priority and work on those. Yeah.
Right.
Yeah.
In fact, there are several items there, by the way, that we put together almost a year ago,
Yeah.
maybe 2 years ago.
Yes.
I think some of them are still valid in a sense that we still have to should work on. But at that time we kind of deprioritize them because we got these big items to work on. So maybe we can
Maybe
revisit that.
Yogesh, maybe next week, maybe 15, 20
Yeah,
minutes, we'll bring that list and
yeah,
add
it would
any
be okay
missing things and
to.
prioritize.
Yeah, we need to. I'm sure that list we haven't touched it in a really long time.
3 years,
So
I think. Yeah, 3 years
there
when
will
we
be
started it.
things which we already covered as part of. There may be some more refinement over there, and there may be some new things too. So
Yeah.
yeah, we can do it. Good suggestion.
Let's get through I think it's gonna take more than 1 or 2 meetings to finish the in-band up, but hopefully we can.
Yes, it will take some time. So let's. So if there are no other opens, shall we start with the in-band requirements document? Okay, Anil is
Sure.
sharing.
Yeah.
Yeah.
Let me know when you can see it.
It's working on it.
Yep.
Okay. So today there are two things that I'm thinking to review. One is in this section where we are defining the error handling capabilities proposal. Drew has added additional clarity on these error types. So that's one topic to kind of review and Drew's proposal and then kind of brainstorm. And the second thing that I want to cover is in this chapter 6, solution architecture. I have added this in-band further clarity on the in-band flows and with an example for the AER errors. And this actually came out of the discussion and the proposal that I think John put together. Drew, sorry,
It was John Clinton and I.
Yeah, John Clinton.
And yeah, John Pando at Google. This is when I was still at Google. Yeah.
Right. So, and I liked his idea and his proposal, some part of it. So I didn't go through the whole thing. So I kind of added some component from that document here, which I believe makes sense. And I would like all of us to kind of review it, and maybe here we can review it and brainstorm. Then in this same section, same chapter, I got one feedback from Vilas. So earlier we had this very massive this drawing, which includes in band and out of band, and kind of getting too difficult to understand. So what I did was I first showed only in band part because there's a new thing. Make it a little bit more clear. what the intent here is and what all
Anil,
these.
can you zoom little bit?
Yes.
Thank you.
Thank you.
Yeah, and a lot of the complication from the previous drawing came.
Sorry, Drew. Is it better, Rama, or do you want to do one more?
Yeah, one more is good, but
One
yeah,
more? Okay, 1 second. Let me just fix that so that we all can see. Okay, how's it?
yeah, this is better. Yeah.
Okay, Drew, go ahead, please.
Well, the previous drawing had things that we thought we were going to need in the BMC, and we've learned a lot since then. So I could go out and clean out most of that middle section and make it pretty simple. I've got a simpler drawing I'm using other places. So if you want me to if you want to give me an action item, I think we can make the BMC draw vastly simpler.
Yeah, I think that'll be awesome, Drew. So
I'll
let
do
me.
that. I've got the drawing. I just need to refactor this one to match that. No problem. You can give me the action item. I really want to do that because, see, at the time I was being told, well, you need to put dbus and you're going to have to publish all your stuff on dbus. Well, dbus has turned out to be, a kind of a performance problem on OpenBMC. It's like making people buy bigger BMCs just because it's so inefficient. And we've also realized that the hardware fault monitor isn't needed with the RAS API. So, so I think I can clean that up if I can just show a RAS API centric drawing, abstract, and say, well, there'll be some interface on the BMC to grab error logs, and we can leave a lot of the details out.
Yeah, that'll be good.
They just don't add anything, we can just simplify it.
Yeah. So maybe we can defer this discussion once you simplify. So the key thing I want to kind of highlight here is and call out that I try to use this approach to build a story. So here we are showing in band view of the error handling, and then we are kind of adding out of band and then showing the whole thing. Now we could just build one for out of band only and then show this one. That also is possible, so that we are kind of building the story, one piece at a time and then combine.
Yeah, I think Anil, the first one started with outer band, right? You can leverage that one. I think I like having outer band separate also.
Yeah, then what I'll do is I'm starting with in band because that's kind of new thing. And then I'll keep the outer band the way it was and then add the combined together.
Yeah.
Okay, I'll work on that.
Okay, now let me clean up the out of band picture first, if you don't mind, and that'll make your life easier because I'll make you a lot more room on the drawing.
Yeah, sure. Thanks, Drew. After that, not for today, but I just want to kind of set the stage. What we had was this additional sort of example. Let's see. The figure shows, this is just a description of the previous figure. And I think this section is a little bit, maybe we need to kind of restructure this as like an example, which is actually in the next chapter. So this whole should really go into error handling flow example, I think. Too. Is it correct, or you wanted to keep this section part of the system architecture?
I don't know. Let's that you're raising a good issue. I need to just go look at it. I think.
Let's
off the top of my head.
Yeah, so there's a little bit of more cleanup work required in chapter 6, and then chapter 7 is the one where we really want to then, after finishing chapter 6, we want to then zoom in on chapter 7, and I added few more examples which I need to still work on it. But if other folks want to chime in and start writing details here, then that'll be awesome. That way we can review the work and focus on chapter 7 only. That's the overall my game plan. Any thoughts, comments?
Sounds good to me.
And this is the last chapter, by the way. I think after that is let's see. After that is sorry, chapter 8 is there. Oh, things are moving very fast. Sorry. What happened here? Okay, slow down. Complementary enablement industry. Oh, okay, yeah. So this one, I don't think we need to do 'cause I think we already incorporated inbound, outbound both here. But we can revisit this one also. And offline, anybody wants to take a look at it and add your comments.
Well,
Rajan.
I do think we haven't done all the complementary, and like I think that may be like a next step for us, is to say, is to review all of the efforts that are underway and say what are the things, the complementary efforts in the industry that still are holes.
Mhm.
I,
Yeah,
I
yeah.
don't I don't think everything's being worked on that we've
Yeah,
talked.
yeah, yeah. We learned since we published this, right? We learned a lot, so we can revisit and refine further.
Yeah.
Yep. So that's, I think, is overall picture. I think you're right. It'll take maybe a few more meeting at least to get to like a finish line, but we're getting there.
Yeah.
Yeah. So with that, I think maybe we should go back to the error classification and the fault scenario that you added. And let me scroll up back. Okay.
Yeah, one of the things that I noticed was Dean, you'll be happy to know that I took your feedback to heart deeply. But if you scroll up, Anil, you made a change, and I guess I want to question that. So a non-fatal, non-recoverable error is not fatal. So by definition, reset is feasible. I think that's extraneous. It's like part of it's what it is.
Can you point to where you're talking so I can focus?
Yeah. I mean, like right there. So what I did, the thing I was telling you, Dean, was I got rid of warm reset as a necessity. Warm reset is an implementation choice. But then, and I got rid of reset may be feasible below, because reset isn't really the factor. Reset, the real factor is who is running well enough to gather error logs. So like in this particular case where you have a non-fatal, non-recoverable error, things are generally working, but you just the OS needs to crash. So you're kind of broken. You need to go down. It's not a deferred error, but the OS can run because it's non-fatal. That's kind of like the definition of non-fatal. And the next one is fatal, and so what I said is system firmware can collect error logs, and maybe it's firmware can collect error logs, but my point was that the application cores or host compute unit or whatever you want to call those processors can can do something to gather the error data, and it might be a warm reset. It might be what we did in the old days at HP. At HP, we understood the chipset and processor design deeply. When we had a fatal error, what we would do is we would crawl out. We'd jump into some error handling code. We would check the caches to make sure the caches were good. We'd check that the rest of the CPU was usable. We'd check that I/O and memory were usable, and we'd slowly crawl out. And if the system was viral, we had a way, we called it plunging the fabric, and we had a way to plunge viral out of the fabric and stop viral flows. But that was super elaborate and difficult and unsustainable. And so folks create a shortcut called warm reset, where you reset the processor, some things were sticky, and you gathered data. The problem there is that warm reset loses configuration data that might have played a role in the error. Just as an example, I saw cases in my last job where some code was changing some settings, and that was the source of the error we were having. So you don't get the configuration settings with a warm reset. It was difficult to debug that way. And so it might be that you get the error logs from a management processor or some other method. And you could even have a management processor gather the errors on a fatal data on a fatal error and make it so that system firmware can collect it and reveal it to the OS via the BERT or HEST. So this is the point that Dean made last time. Reset isn't really the factor. The factor is who can collect logs.
So I think I agree with everything you've said. I want to be careful that you don't prescribe a particular way that the hardware and firmware, and maybe even the OS, has to operate. The goal is to collect the data, and in particular circumstances, some methods might work and some might not.
Exactly.
I think that's all good stuff to say.
Well, and what I'm prescribing is that in this case, firmware can collect error logs. So if you're doing OS first, the CPU's able to get the error logs from the firmware. That's it. And I'm not prescribing any details. Although I would really like to use the existing ACPI tables if practical, but I'm not even saying that here. I'm just saying it can be done.
Sounds
So,
good.
so Drew, I am in my mind. This is the scenario where crash dump would be useful. Do you agree?
Maybe. So yes. I think crash dump is useful in this situation, but it isn't necessary because system firmware can run. So it is useful, and the system firmware may be able to run, but the OS may not be able to run. And so the next case was, where the system firmware cannot collect the error logs, and in that case, you have no choice. You absolutely have to crash dump because you can't run code on the host anymore.
So when you say system firmware can collect log, you are talking about SM handler populate the birth table and reset.
I'm not saying SMM handler. I'm saying system firmware. I'm being very generic. It could be.
Can you give me example?
I mean, it could be L3 code, but I don't want to use system management mode. It could be that you system firmware doesn't collect them directly. You could just have a management processor say, "Oh, your host, I'm triggering an error reset. I'm going to go gather the error log and hand it to firmware to pass to the OS on the next boot."
And does, I know you said system firmware, does firmware running on a management processor constitute system firmware or a different kind of
No.
firmware?
I define system firmware as BIOS, UEFI. I've actually
You
defined.
gave those as examples. You didn't define it that way.
No, I'm talking about
are you restricting it
in the
to?
glossary. I defined it that way.
Okay, so you really want to say it's firmware running on the application processors.
Well, but I don't know that application processor is a universal term.
Okay, pick whatever universal term there is. It's
System
not the
firmware.
management controllers, even if they can run and fetch the data.
Well, the system firmware can collect the data at the end of the day. I'm not prescribing how it does it. It could work in concert with a management processor. It could use warm reset. That's the whole point. Is we're not saying how.
Okay, okay,
We're just saying that it can, one way or the other.
okay. Can is good.
Right. That's all I'm asserting here. And that's nice because I always felt like I never loved warm reset, to be honest. So I feel like you lose too much data on the reset. So um,
So,
but
Well,
before
I'll make a point that all these things are sort of defense in depth. So there's not only one solution, there's a series of backstops, right? And so if the OS can't collect it, maybe firmware can. If the firmware can't, maybe management processor can. If the management processor can't, maybe a warm reset can. And it's a series of things. It's never only
well,
binary.
that's kind of this whole flow of tables. So the errors get more and more severe, and then you have different ways you
yeah,
collect it. But my point
yeah, actually, sorry, if you go, so this is actually where we started describing the sort of error handling error handling capability itself. But before that, we defined this error category and we use the approach Dean you just mentioned, right? So if you look at here, right, we start with defining the fault type. I think you made one more good comment there earlier that, hey, is it a fault or error? So maybe we should call hardware error type.
look at error
Right?
type. Yeah, it
Yeah,
is error type.
yeah. Uh,
But my point, yeah, and I need to go back and change this table. I think that the problem is that
Drew, before you change, I want to first walk through because I think what you're defining a new category which is already defined here. So before you
it's not a
jump,
new category. It is a category that is already here, and I just cleared up the definition of it.
yeah, I want to first clarify maybe that we don't need that clarification further. But let me just walk through that, right? I know we've kind of glanced through this one multiple times. So corrected errors. And in that case, platform shall return the control to the OS contacts, blah, 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 and basically,
I
correctable
think that
error.
one's clear enough. Yeah.
right? Then non-fatal recoverable errors. So in this case, platform shall capture error logs in a way that makes them visible to the CSPs. Platform shall return the control to the OS context. So this is important, right? So in this case, the OS context is maintained because it's recoverable. And so this is next sort of severe error. Then after that is non-fatal reset feasible. So this is
Yeah,
the next.
and this is my problem. Is
Mhm.
that with all like who cares if the reset's feasible? The reason we said reset feasible is that error logging after the reset was feasible. But my point here is it's not really the feasibility of the reset we're talking about, and that makes this table confusing. And furthermore, it assumes that warm reset is the answer, and that is also a mistake. So that's where I think we've kind of messed things up a little bit. This isn't about feasibility of resets. You can always pull the reset pin and see what happens, but it's really about whether or not you get error logs from the application cores, to use Dean's term, at any time after a reset.
So, Drew, just a quick question. I was trying to understand the error classification you have here. Is there any reason that we are not aligning with the industry standard classification there of SDCs, DUEs, and DCEs?
Well, yeah, this aligns with it, but it's a superset of it because it's who can log it.
Yeah, so Jyotika, this is further fine granularity into DOE.
I
Okay.
see.
Well,
I see.
well, CEs are CEs. You know, we're doing UEs and Cs, right?
Yeah. So this is all DOE. Like non-fatal recoverable is DOE, non-fatal is DOE.
The first one is
fatal-
CE, but the rest are DUEs,
Correct.
as
Correct.
Anil was saying.
So maybe we should. I don't know that. Sorry, I haven't read it, but maybe we should say that somewhere. That's where.
Yeah, we have made that clear earlier in the discussion, but take a look at it, and if you do not find that, then just raise somewhere, add comment, and we can do that.
I don't know.
Okay.
I don't see that. I mean, I think we could just put a sentence.
Yeah.
Put a sentence on the hardware error classification, right?
Yeah. Let me just add a comment, add a reminder for me, and then I can do that.
Yeah. But I guess my point is, like, we're not talking about whether, like this was always this is why this confused me over and over again, and Mark Fletcher and I had to debate it repeatedly. And really the point of it's not reset feasible, it's that we can log errors and get them on the reset.
So what do you want to call that?
So non-fatal is just don't need anything else. It's non-fatal, and it will be, that's it. That's all you need. And the OS can run. We just say that all the definition is good as written. The OS can panic and run, and as it goes, it can go through its crash path and gather data. No problem. And so reset feasible is irrelevant here. It's non-fatal. And so fatal says we can no longer run code anymore. But what we're saying is that some fatal errors you can run code, and you just can't run the OS. But you can run enough code to gather the error log, and get the data. And so I don't see any purpose of the reset feasible and non-fatal. It's inherent in what it is. It's
So basically non-recoverable, because this is the class, Drew, where we call that out, that kernel should
non-fatal, non-recoverable is perfect. I'm happy with non-fatal, non-recoverable. That makes more sense to me.
Okay, then let's call that out. Non-fatal, non-recoverable.
I mean, that's what it's called in one column to the right. So yeah, sure. That makes a lot of sense.
Which is okay to call that out with two different contexts.
Yeah, sure. I mean, one's the severity, one's the fault, the error type. Yeah, whatever.
Yeah,
that's fine. Yeah. But now, if you look at the fatal errors.
Okay, then So now next severe error is fatal. Now within fatal, then we further classified the reset feasible, the voltage regular faults, where reset itself is not feasible because of the voltage regulators. And the last category is that the BMC itself is the host.
And
So
so let's look at fatal. Okay, reset feasible is not really saying anything. This isn't about resets. It's about how do I get the error logs? That's really what we're trying to figure out. And that's what this whole document is about. How do we get the error logs for each of these cases? And so for fatal errors, you have some where the firmware can collect the error logs, either on the next reboot with a warm reset or from some management process or something else. And then you have fatal errors where the system cannot run code, and that you could argue that collapses into the VR faults. But it's kind of a separate thing. I mean, when firmware is unable to run, let's say that you have you had one DIMM in the machine. That one DIMM's dead. Now firmware and software, firmware and the OS aren't going to run anymore. Um, uh, so now you need to log the error. You can still log that error out of band, but that's fatal, because what would happen is you take a nested, uncorrected error as the DIMM, as you notice the DIMM failure. That's a fatal error, and you're not going to execute code anymore. But out of band tools could conceivably log the error and send a CPER.
So I was zooming on further on the firmware. You mentioned system firmware, and I think I wasn't getting very clearly. So you're saying the system firmware means not the BMC firmware, but something else. And
The BIOS. I'm just using system firmware as a generic term for BIOS.
Which is SMM handler.
No.
Then what it is?
So you cannot presume that it's the system firmware handler. So again, I'll repeat it. You might use the SMM handler. We don't want you to. You might don't think of processor architectures that you know. Think of something more generic. On an ARM processor, you might have a management core that it can go gather the data. So you reset the machine, system firmware comes up, and lo and behold, it's got an error log it can pass to the OS.
So I think maybe we can call it platform firmware then, because system gets blurred in my mind, because system means too many things.
I've defined it in the I defined it in the but hold on. No, platform firmware is too general, because the other thing you could do is a warm reset. A warm reset is a viable option here. So the system firmware is able to run well enough on a warm reset to collect the error log. But my point is, don't think of this in terms of processor architectures exclusively. Warm reset.
I know the architecture that you're talking about also, and I understand what you're saying. Basically, dedicated engine, which is outside of the execution cores, get the notification and can collect some information, and then do a reset.
Or you can do the old school
or
hardcore HP crawl out. That was okay. So that's the point, though, is that at the end of the day, system firmware can get the error logs and pass them to the OS somehow.
Neil, let me emphasize one of Drew's points. On ARM processors, system firmware is not SMM.
Yeah, I know exactly what you're talking about.
Okay,
and I'm
so
dealing with that right
it's
now.
still running on the main cores, whatever we call them, but it doesn't rendezvous all the cores. It's not SMM. So yeah, it's very important not to equate them.
Yeah, absolutely right. I was just making sure that I'm not thinking the same way that Drew is thinking, and he clarified that it's not SMM. I was not saying that it is SMM. I'm just asking.
Well, it could be. It might be SMM. It might be EL3. It might be a warm reset. It might be crawling out. It might be getting the error logs in the next boot from a management processor.
Yeah.
But the point is, at the end of the day, system firmware can get the error log and pass it to the OS.
Yeah, and I'm okay with that, because somewhere we have defined even the block diagram that we put together, right? We talked about quite a bit on that block diagram. Let's see. I think we simply said firmware there. Sorry, I'm scrolling down, yeah, right here. Oops, moved too fast. My bad. My computer is really slowing down because I've got too many things going on.
Mine
Okay.
does it when I need to reboot it for an update too. The longer you wait, the more
Yeah.
it slows down.
I think what you're referring to is this firmware that could be
Yes.
an internal controller, or could be carved out on one of the application core. Multiple ways to implement, or
Well,
SMM, right?
but no, but at the end of the day, it is the system firmware that talks to the kernel. The key is that you have a piece of firmware that runs in the system that can pass the error log to the kernel. And so
So,
it totally fits the strong, and you know, just passes it up. That's great.
so
Drew,
you calling
why do
this
you
as
mention why do you mention the kernel here? I thought one of the purposes of this exercise was to avoid the kernel in some cases because the CSPs don't have control over the kernel.
Oh, absolutely. So for the bare metal case, so Dean, we're talking about bare metal and infrastructure and application, and
Okay,
so
then I agree. It's the kernel's job to communicate it further, right? And I'm fine with
Yeah.
that.
So for our infrastructure and application, those users may choose to do it through the kernel, and you know, like a lot of places, they can't afford to make the investment in a bunch of different ways. So a lot of cloud providers may choose just to go out of band, you know, for the purpose of service actions because they can make that work for all their users. But we're doing it both ways here, and so that's kind of the purpose of that table. And so what I'd say is I'm giving Anil a point here that that should make him happy. That I agree with him that you know firmware can sometimes get a fatal error to the OS, and that can be logged in manned. Not all the time, but sometimes. And so that's the case I'm calling out here. Sometimes things are so screwed up that system firmware is not able to run, the kernel may not run, you know, things are just really hosed. And in that case, you don't have much choice. You just have to log out of band because your in-band management agent never makes it up.
So Drew, I think I'm getting now your point. So first of all, when you call system firmware, I think in this diagram I was calling firmware. Should I change this to system firmware? Because if you're kind of,
Well,
let's make sure we're consistent on that
yeah,
definition.
yeah, I don't really care. I don't want to call it platform firmware because platform implies all the management firmware, and I'm just saying the firmware that talks to the OS.
Okay, that's okay.
But-
Let's just define the term, right? And if everybody agrees with the system firmware, I'm okay with that. But the scope is here, right? This is what you're calling system firmware
Yeah,
now,
yeah.
right?
And if you look in the glossary, I did define it.
Okay, we'll go over that later, but let's just finish this error classification so that we at least
Okay.
close
And
on.
so Neil, the big point I was trying to make here is that sometimes with a fatal error, you can get it through the OS. You know, it's a warm reset or something. There are lots of different ways to tackle that, but sometimes the OS gets fatal errors. Sometimes it can't because it can't run. And so those are the two cases I was concerned about in the
Yeah. No, that's fair. So fatal system firmware can execute. Is that what you're saying, or you want to call it something else?
that's what I was calling it.
Okay.
Well,
So
this firmware can collect error logs.
well, the collect analog is getting a little bit more
Okay.
prescriptive
We can
here.
say system firmware can run. Yeah, I'll
Can
change.
execute. Yeah.
Or execute.
And
Wait,
go ahead.
just tell me what you want to. Do you want to say execute?
Yeah, can execute. Yeah.
Okay.
Unless somebody has some other thoughts.
Fine with me. I'll make the change up below.
And the platform shall capture error logs in a way. Should we call it system firmware? Because I think now since we calling that system.
Yeah. So can I just check, because Drew, you said something, and I don't think that's what's written, and I just want to check and see if, you know, you said it wrong or if it's written wrong. You said in some cases the kernel can execute, not the system firmware.
No. I
Oh.
don't think so.
I just want to make yeah, that's what Drew said. As long as he,
Oh no. Oh, I guess my point is on the next boot. You know, the kernel may be able to come up
Okay.
with not depending
Okay.
on the next layer.
Yeah,
Now,
okay.
now actually, I'll go even further, Vilas. On that HP crawl out approach, they would take a viral error that was nasty and recover the system, plunge viral, and hand off to the OS crash dump
Hey,
handler.
Drew, you're getting into some very specific implementation. Let's not go there.
Yeah, no,
No,
that's
no,
fine. I just
but
wanted to make
I'm-
sure
my
I understood what you said. That's fine.
my
So,
point
yeah.
is, but my point is very specific here, is that you can either run code or you can't after the fatal error on the host, and it's all about system firmware being able to do something, because if system firmware can't come up, it doesn't matter. The OS is done.
I mean, at a very high level, I think if I want to simplify that, right, there are certain fatal cases can be reduce the severity to a sort of non-fatal, non-recoverable concept, and then you can collect the logs. That's, I think, is what we can. I mean, within generic term, we can say that's like a
Well-
DPC concept, right? The uncorrected error becomes can be signaled as correctable error, and kernel can collect the logs.
But a fatal error is different, because you're not handing off to the OS without heroics. So
I'm
that,
saying some fatal errors can be
Yeah.
severity can be one notch bring down
Yeah.
to same as
but
non-fatal concept.
Drew, you said something now that I also don't agree with, which I think Anil is also not agreeing with, right? You said code can run or it can't, but there's cases where system firmware can run with it, like a kernel can't, right?
absolutely.
Yeah. So
Yeah.
this category what we're defining here is the
Yeah.
next severity,
Okay, that's
where
fine.
the only possibility here is system firmware or BMC
Yeah,
and or
okay.
BMC, right?
So the BMC, you can certainly log that out of band, probably more reliably.
Yeah.
Correct. In fact, that's exactly what I was pointing out, and I asked that question. So this is the category where now BMC becomes relevant, where crash dump concept would be one way to collect the logs.
Well, but I guess there's also the fatal system firmware cannot execute, and there you absolutely have to use crash.
So now here, I agree with you. Maybe at that time we didn't know how to call this one, so we just had voltage regular fault. But
Oh,
I
no,
think
no,
you're
that
bringing.
Oh yeah, I don't know. That
I
one.
think no. I think this is no. You're bringing a very good point, Drew. So this is the category where system firmware cannot execute, or you can call BMC firmware can execute. I mean, basically,
Well-
this is next severity, right? Where system firmware is also host. Like VR is one example. It could be some other like hang kind of situation where even firmware hangs. Right?
Yeah, when we discussed this, Mark Fletcher pulled me through the knothole on this one and what he meant. And what he meant here was the difference between firmware can't run and a VR fault is that you get no error logs from the CPU because it's not turned on. But that's kind of splitting a hair. So if you want to make that one fatal, system firmware cannot run, and you know your mileage may vary what logs you can get with you know, but there are some cases like where it's fatal and system firmware cannot run, where you can get error logs still. It's just the CPU can't run, but the BMC could get some things.
Correct,
Or a management processor. And then there are other cases where it's the case that Mark imagined, where the power is off and the CPU is not running at all, and
Right.
you get nothing. And so maybe what we do is.
No, hang on, Drew. I agree with what you guys are saying now. I actually don't agree with Mark's point, right? Like, or I understand Mark's point, but the way to solve that is you put detection on your voltage regulator, you put that on a separate power rail, and then you get a log that way, right? Like, if you care about that problem, you can get a log.
Oh no, but that was Mark's point. If you look at that table, fatal VR faults, it says BMC based fatal, since the BMC can run and log the error and housekeeping power.
Yeah, that's fine. But it's just a case of system firmware can't execute. Like, that's just, you know.
Okay, I think what we can do is merge those two cases, and then just note that you know, the CPU in really bad cases, you know, the BMC may not be able to get anything from the CPU, but it may be able to detect things environmentally like power faults, and we're good. We can just merge the two, because at the end of the day they look the same, in that the BMC has to do all the logging.
Yeah, I was gonna say one thing that I see mistakes being made is that when errors are not distinguishable, and what it turns out to be well, it looks like a Byzantine error, right? Where you can't really pinpoint, you know, depending on your point of view, what the root cause was. So Be very clear. Don't have these duplicates. I agree with you.
So listen, I like that, Anil. Let's merge the two, and I'll take the action item to merge the text below, and and then just make it include Mark's use case, and make it.
Which two? The fatal system firmware can execute and
No, the VR fault and system firmware cannot execute. So you've renamed this
that's
table.
the same thing.
Yeah, leave this one as written, but I'm saying down below.
Yes.
I'll merge those sections.
Correct. So and these are the example, right? VR failed, the whole CPU cannot run code, but BMC is still alive. CPU crash or hang, preventing further code execution. In fact, I can say CPU,
exactly.
firmware, system firmware, CPU or system firmware, right?
You may have lost all of main memory for some reason,
Yeah.
So, like I will merge these sections below.
Right. And this is clearly the only way we can collect the log is through crash dump. Yeah, crash dump. Yeah.
Through out of band. Yeah.
Out of band. Yeah.
The reason I say out of band is that you may not be able to get a crash dump, but you may be able to get your voltage regulators broken.
No, that so Drew. So one second. We are failed.
So the point is that when I go to a silicon vendor and say, "Give me your crash dump," they're not going to know if I use a micro semi or TI or Motorola or whatever power regulator, right? That's the main board. So when I get a CPU crash dump, that's different. But I expect to get CPER error logs from other things like VRs as well from the BMC. So that's my point, is that in some cases the crash dump may not succeed, but we would imagine that we can get some other error logs about the system from the BMC that would guide it.
So maybe the confusion here is that, so in my world, right, when I collect the crash dump, I collect not only the error log, but also the temperature and voltage sensors coming from other GPIOs. So my crash dump actually include all those stuff. Okay.
Sure.
So that's how I can then determine, oh, I see the voltage is down.
But that's an implementation choice. And if I say, hey, Intel or AMD, give me a crash dump, they're not going to know what voltage regulator you use necessarily. Right?
Yeah, but Drew, I'll say it, Anil's definition of a crash dump is really a better definition. It's the platform. It's dumping, the crash dump across all the platform, right, or the node, right?
Yeah, it's inclusive of everything that you can collect, right?
Yeah, that's right. Yeah, the CPU or the GPU or whatever is part of that, right?
So,
but
let's say that then we'll just be explicit that the CPU crash dump may fail, but the BMC may have other crash dump.
Yeah, if you further want to classify within the crash dump, CPU versus BMC versus VRs, then yes.
Well,
but I think
I'll just include that in the section. We don't need a different section for it.
Yeah. So I think we are on the same page now that we're going to redefine this one as a system firmware cannot execute. So that's the next severity, right? And then the final one is where BMC is host.
Yeah.
Right. So I'm calling BMC voltage regulator fault, but maybe we can say BMC cannot make BMC is failure. Maybe, I don't know.
Unavailable.
Not available. BMC not available. That time we were kind of thinking VR as an example, and we just called that out. But I think we can always do better job than just calling VR, because VR is one example, right? It's not the only example.
I don't. But let's see, voltage. Where's the voltage regulator faults?
No. So the last row.
Oh, I see. We didn't even mention that down in the text below.
No, we did not, because this is the category I fought to add it here, because everybody was saying, oh, this is out of scope. I said, no, I want to have this category. We can always say, okay, this is out of scope of this document, but at least this is a class of failure that can occur.
It can happen. Sure, it can happen.
Yeah, and we need to acknowledge that, right? Nothing can be done. I mean, if the BMC was all bets are off.
Well, I mean, what you do is you find the machine's not responsive, and someone's got to go take a look at it. Yeah.
By the way, the reason I wanted to put this one is because if you look at this hierarchy here, right, it looks like last row is like all bets are off, right? But there is a possibility where we keep the BMC and the CPU, the host, like a two different power domains. And it is always possible that BMC is completely down. Let's say power is down, BMC hung somewhere, but my host is still running. I mean, it will eventually go down because somebody will come and say BMC is down, so therefore take the machine down, right? But host is still running, and I can collect the logs from there, or I can at least pull everything as possible before I take the machine down.
So it's an
So there,
internal BMC error rather than a power issue.
say again.
So it's like an internal BMC error which caused it to reset or shut down, but it's not related to power because
Yeah, I
It's
mean,
not related to the host. Yes,
standby rail.
it
So
might be power, it might be just the BMC is broken, right? I mean,
exactly.
if
And we
like if
keep it intentionally like that.
like if it is power, generally if BMC is on a standby, I think FPGA will also cause the main power domain to bring down. So
Yeah,
it's
not
unlikely.
not all failures are equal, and if the BMC is down, that's a specifically, crucial critical outage.
That's
So
right. We definitely want to call catastrophic, but all I'm saying is that, again, this is an implementation detail I'm going there, right? We can partition it, and we actually done that, where even if the BMC goes down, our host is still alive, may still be alive, and I can still access it remotely and collect the data before I pull the machine down.
I don't think you can collect any data or as much data at that point, but you
Whatever
could,
I can collect from host, right? Because
Yeah.
see, BMC is sort of in a separate domain, right? And the host is still executing, running.
I
Of
think
course,
it was the case, Anil, like maybe few years back. Now with all the liquid cooling on, like BMC become very critical part of it. Without BMC, I don't think with the thermals, like liquid cooling, you can run the system. Like I agree, like 10 years back, like even in Azure environment, BMC is not available. We still run the VMs, but not in our scenarios. We don't. Yeah.
the
you're absolutely right. You're absolutely right. All I'm saying is that to collect the logs, right? The class of the errors that we can collect the information where the BMC itself fails, there is a possibility that we can. Okay, maybe the context I'm making here is that this last row seems like all bets are off. The only thing we can do is somebody has to come from outside and reset the whole machine, and we may lose pretty much everything, all the errors, right? That's the kind of class.
Yeah,
we
I
follow.
mean, Anil, the point you were making, right, is if you care enough about this class of error, there are ways to do things, right? I think the point Drew and Rama are currently making is the current system designs sort of presume they don't care enough about this type of error to really do something special. That's fine. But like, yeah, just call it out separately, right? It's clearly a different class of error.
And you know what?
Yeah.
I mean, like you could even create a solution where the management processor on a smart NIC could pop in and grab some stuff and figure out what's going on. So, but I guess can we just say that I'm fine with having this category? Can we just say, yeah, we're dead for now? And
yeah, that's all we concluded. And I'm fine with that. I'm also concluding right now. Also, that's what we call BMC cannot capture any log, hence out of scope for this proposal. Hardware must have capabilities for diagnosing the issue. For example, power LED does not light, things like that, right?
Hey, one thing. So in between the third last row and the second last row, does it make sense to also include like EROT related authentication failures where that's not exactly a VR failure, but because of the image failure, you're not exactly able to boot the system firmware as well.
Boot failure, you mean?
Yeah, it's a boot failure, but the system firmware can't execute, right? So it's between like the third last and the second last.
so like a bad key in firmware or something.
Yeah,
Like
a bad key.
measurement. So security.
I think you're bringing a good point. That actually is another example where is a fatal system firmware cannot execute. Boot time
That's
failure.
what I call that. I'd call that one fatal.
Right?
Yeah.
Yeah, so this is like a boot time failure, right? Boot time.
I will include that as the list of reasons why. Yeah, I think that's a good. I'll put that in my list.
Yeah, good catch. I agree with you. because it's another class of boot time failures where system firmware like memory training crash. I mean harm, right? And
attestation failure, like
attestation failure. Yeah.
I'm just going to say it includes cases where there's a security issue that prevents firmware from running, and because that's just very vague. I want it to be broad, right?
Yeah. No, I'm just example, right? Example.
Yeah,
Attestation failure.
that's why I put it as an example in that firmware can't execute. That's a good one.
Right.
Yeah.
Platform shall capture logs in a way that makes them visible CSP shared. And yeah, okay, cool. I think this is looks like we are converting now on the definitions.
Another the last one, BMC not available. You want to say out of scope for out of band proposal only, or you want to say this proposal there?
Let's keep it this proposal for now. Then maybe in the next 2.0 version, as we can become more and more mature and.
This applies to working band and out of band, right?
Hence, BMC cannot capture any log, hence out of scope of this proposal. Sorry, what are you saying?
Or which proposal? This was originally written when the proposal was only out of band. Now we are editing it for out of band and in band. So question is, do we think that BMC affects in band and out of band equally, or we think that maybe this affects only out of band?
No, this is okay. This is fine. I think this is for now. Let's keep it there. I think the point I was making earlier, and you were bringing also a good point, where like in-band approaches is where I can design a system where my dependence on BMC is limited. Therefore, if BMC fails, I can still execute up to some extent. I agree with you, liquid cooling and all that Rama was mentioning, right? We cannot leave the machine running for long, but at least I can collect the logs and then take the machine down. Okay, yeah. That means I'm not completely deep in the water, right? But let's keep it out of scope for now. And in the next release, we will expand further. Maybe we'll bring liquid cooling in the discussion. And
well, I'd like to. I think we need a much deeper. I agree. We need a deeper discussion because like we need to. If we do it, we need a way to make it. We need to think about a general approach, and I think that's going to require a lot of discussion. So it would be better if we just got the in-band stuff out and then dealt with that later.
Yep. So if everybody
almost at the end of the time, so let's wrap up in 2 minutes.
Yeah. So if we are okay, I want to just accept these changes, or do you want to chew on this and then come back next week?
I like them, but I'm biased.
Let's see if we still see any issues with all of them.
Okay, and I'll clean up the VR fault stuff. I've already started, but I'll clean up that section in the table.
Yeah, and thanks, Mita. I think you did quite a bit of edit. I appreciate. Mita there?
I think she left, or I haven't seen her today. But we can record it for posterity. I really appreciate what she's doing.
Yeah. Okay, cool. I think we can call the next week. We will now with this clarity on the definition. Let's revisit this table, right? And we'll review this one and then convert this one. Okay.
Sounds good.
Awesome. Thank you.
Okay. Thank you. Talk to y'all later.
Have a good one.